Hi guys! Okay, our topic is electrochemistry and this is the last third of chapter 17. My name is Kathleen Yang.
I am Jennifer Zhao.
And I am Jack Ding.
Okay, so let's start off with some key terms from this section. So first we have to know what an electrolyte cell is, and this is where the cell uses electrical energy in order to produce a chemical change. And also we have to know what electrolysis is, and this involves forcing a current through a cell to produce a chemical change for which the cell potential is negative. And a galvanic cell is a cell where it has a spontaneous reaction that does not require an input of energy. Basically, the difference between an electrolysis and a galvanic cell is that a galvanic cell is a spontaneous reaction that means it occurs on its own, and for electrolysis, it involves another source in order to make the reaction occur. Finally, we have to know the stoichiometry of electrolytic processes, which is basically asking how much chemical change occurs with the flow of a given current for a specific time.
So the stoichiometry of electrolytic processes. Silver is deposited on objects in a silver electroplating cell. If 0.175 grams of silver is to be deposited from a silver cyanide solution in a time of 10 minutes, predict the current required. Write the Bounce equation for the half-cell reaction by first listing out the measurements and the conversion factors. So then, after that, you convert to moles using the mole ratio, and which then you would convert to the current. So first follow these steps. You look at the current and time, and you would convert that using the quantity of charge in coulombs. Then, using the moles of electrons, you would convert those moles of electrons into the moles of material, and from that you would use the molar mass to convert to the grams of material. For an electrolysis of a mixture of ions, the more positive the E value is, the more the reaction has a tendency to proceed in the direction indicated, which also means that it's spontaneous.
So the next section talks about commercial electrolytic process. Metals are typically the best reducing agents because of their ability to easily donate electrons to form ions. Noble metals such as gold, silver, and platinum are more difficult to oxidize and are often found as pure metals. So for key terms in this section, scientists Charles and Paul discovered a practical electrolytic process for producing aluminum. The Hall-Héroult process uses molten saccharide as a solvent for the aluminum oxide. Electrolysis is possible only if ions can move to the electrodes. Electrolysis also can purify metals as well as metal plating. Downcell is a cell design so the two respective chemicals cannot come into contact with each other to form their original solution. A mercury cell is a cell where mercury is the conductor and can be used for electrolyzing lime.
Okay, finally, we just have some miscellaneous tips to help you for the AP exam. So this topic isn't covered that much on the AP exam, but if it does show up, it's normally in the free response section, so you should really brush up on the stoichiometric process. And also, this chapter really goes hand in hand with redox reactions, so if you had a easier time understanding that, you'll have a easier time understanding this section as well. Okay, good luck!